So far in this module, we've been talking about how to secure internal routing protocols, so let's shift gears and talk about how to secure BGP, which is most commonly used as an external routing protocol. For this demo, we're going to be configuring BGP on routers 1 and 3. Router 1 will be part of Autonomous System 66001, and router 3 will be part of Autonomous System 66003. Here is a basic BGP configuration for router 1. I manually configured the IP address of 12.12.12.1 to be the router ID. I added a neighbor statement pointing to router 3's IP address of 23.23.23.3 and its AS of 66003. And then finally, I added a network statement of the 1.1.1 network. On router 3, the settings are the opposite. Its router ID is manually set to 23.23.23.3, and the neighbor statement points to router 1's IP address of 12.12.12.1 with the AS of 66001. And then, of course, I added the network statement for 3.3.3.0. Since these two peers have different autonomous systems, they are external BGP peers. However, because these BGP peers are not directly connected, which means they're not on the same subnet, we have to add an additional neighbor command. This is because by default, Cisco routers automatically set a time to live value of 1 for any external BGP peers. Traditionally, the command to allow peers to connect was the neighbor ebgp-multihop command. However, a more secure way to configure multihops is with the neighbor ttl-security command. This allows us, as administrators, to specify the exact number of hops away that the BGP peer can be in order for a neighborship to form. This doesn't just protect against peering with an unauthorized neighbor, it also helps prevent a denial of service of the BGP process. If an attacker tries to perform a CPU exhaustion attack by sending a large number of TCP SYN packets, if the TTL is too high, the router will not accept the packet and the CPU resources won't be affected. So, in this demo, we will add the neighbor TTL security hops command to allow for the eBGP peers to form a neighbor relationship with each other while not leaving themselves exposed to a CPU exhaustion attack. Then, just like we have in the previous clips, we're going to use an authentication key. As I stated earlier, this key is hashed using MD5 and configured inside of the BGP configuration rather than on the interface. Alright, here I am in router 1, and to configure TTL security for router 3, I'm going to enter BGP configuration mode by typing in router BGP and then specifying the autonomous system of 66001. From here, all I need to do is add the TTL security command, and that is neighbor followed by the IP address of the neighbor, which in this case is router 3's IP address of 23.23.23.3, followed by TTL-security, the hops keyword, and finally the number of hops, which in this case is 2. So let's jump over to router 3 and configure the same thing. I'll enter BGP configuration mode, specifying router 3's AS of 66003. And just like on router 1, we need to add the TTL security command. Again, the command is neighbor, followed by router 1's IP address of 12.12.12.1, and then TTL-security hops, and we're going to specify 2. Alright, it looks like BGP came up, which shows that these commands worked as expected. So the other thing that I wanted to configure is BGP authentication. To do that, the command is neighbor, again followed by the IP address of 12.12.12.1, and then the keyword of password, and then the password itself, which in this case is global123 with a capital G. Let's clear BGP since this session is already established by entering the command do clear IP BGP followed by a star. Alright, there's our notifications of the BGP reset. Alright, and here we can see the router is complaining that there's no MD5 digest from router 1. Let's take a look at the BGP summary by entering the command do show IP BGP summary. And sure enough, the neighborship is stuck inactive. As a refresher, for a fully established BGP relationship, the state needs to be established. So let's go ahead and fix that by jumping back over to router 1. We're still in BGP configuration mode, so I'll enter the command neighbor, followed by router 3's IP address of 23.23.23.3, the keyword password, followed by global123 with a capital G. I wanted to point out that unlike other protocols that we have been adding authentication to, with BGP, a separate command to enable authentication does not need to be entered. When the password is configured, authentication is automatically enabled. Alright, and it looks like our BGP neighborship has formed again. Let's check the routes. And there's our route learned from router 3. We can tell it is learned via BGP since the B represents routes learned via BGP. Let's try to ping 3.3.3.3. Alright, and that looks good. In the next clip, we're going to shift gears and learn how to secure the data plane on a Layer 3 device.